All right, and we'll admit people.
Oh no, something just happened where it went off of my slideshow.
I can still see it, Valerie, so you're
Yep.
good to go here. Yep.
All right, well, welcome everybody. It's great to see some familiar faces on the screen in the participant list. My name is Jeff Tollefson. I have the pleasure of serving as the president of the Minnesota Technology Association. And really pleased you've joined us this afternoon for one of our quarterly series in the advanced technologies community of interest at MnTech. And really delighted today to welcome Valerie Bergman, a data and AI architect at Microsoft, that's going to walk us through the whole data lakehouse, data mesh, data fabric. Oh, my title is just very intriguing, but eager to hear more from Valerie. Valerie's been at Microsoft for almost 9 years. Before that, close to 6 years at Avtech Solutions, where she was the director of strategic consulting. St. Thomas graduate, her bachelor's degree was in international political science, and how she ended up immediately going back and getting a master's in software engineering. I just can't connect those two dots, and maybe Valerie will explain more. But with that, I am going to turn it over to Valerie and look forward to what should be a great conversation here.
Yeah, so hello everybody and welcome. How I ended up going from international political science into technology is a lot due to my dad. So my dad was always encouraging me to go into technology, and I was kind of resistant. And then with my international political science degree, I was hoping to go to law school, but then life happened and things kind of went sideways, and I didn't want to move out to Washington, D.C. anymore because I was married and I had kids. So my dad was like, you should go back for computer science. And so I looked into it and have been so glad I did. I am kind of a puzzle solver, and I love understanding big challenges and brainstorming ways that we could bring some solution to the table, and technology has the power to kind of change the way the world works. So I am very passionate about helping customers figure out how they can leverage that power of technology to change the way that they do business. So that is kind of what got me into technology and what got me here. And at Microsoft, I work with customers, large corporate customers. Many of them are Minneapolis based, although after COVID, there have been more remote meetings that I've been leading. So I've been connecting with US-wide customers, global customers. And in the MTC, my role is to meet with customers and understand what they're trying to do and help dream up ways that technology can help get them there. I focus on the data and AI space. And so I have conversations with different corporate customers almost every day. So I get a lot of opportunity to see what's going on inside of their technology environment, as well as help dream up ways that we can apply new patterns to get them to solve problems. So I get this really cool insider view into architecturally what customers are doing locally. And I very much love that. And I pivoted over into this data space about 4 years ago. I've been working with data my whole career, but I started focusing in on advanced analytics, BI, artificial intelligence, machine learning, and got really excited about helping customers figure out ways that they could leverage these patterns to help them monetize the data that they have available at their fingertips. And a lot has been happening in the data space, probably forever, but it seems like in the last couple of years, things have accelerated with brand new patterns. So that's why I thought about doing this session today. Is data engineering might not seem as cool and sexy as artificial intelligence and machine learning patterns, but if you don't have your data in order, you can't take advantage of those AI and ML patterns in the same way. So a lot of my conversations focus around how do I get my data from source to a place where it's usable? And there have been new buzzwords popping up like crazy in this space, including data lakehouse, data mesh, data fabric. And I wanted to demystify what some of those terms mean to get everyone up to speed. And I thought to start out, I would talk about the data journey. So the data journey has been not a straight path for most companies. A lot of companies have invested in their data estate and in different data engineering patterns, and they have struggled. They have struggled to get the value out of their data that they are hoping to get. They have struggled to get the speed to insights that they're hoping to get, and they're trying to figure out how they can untangle this mess. And when I first was in technology, like 25 years ago, one of the patterns was, how can we get out of the world where we are reporting just out of our transactional systems and what happened in that transactional system to get to a broad picture of what's going on in our entire organization. And that is when the pattern of central data warehousing emerged. So that was kind of where I entered the data world forever ago, is everyone was trying to get their arms around, how do we get to a central data warehouse and break down the silos so that we can get an end-to-end picture of our customer, an end-to-end picture of what's going on in our organization, so that we can be better about planning our next steps. The problem, though, with central data warehousing is when we were working with central data warehousing, 20 so years ago, we would have a server or maybe a set of servers, a server farms that would hold data from the siloed systems in a way that it was merged together so that we could get to this insight across systems. But the problem is with that server approach, we would run up against walls. So we would run up against ceilings in how much data we could store in those systems. We would also run up against ceilings with how performant our reporting could be if we were crawling large amounts of data. And as we were originally just going to a central store and we were keeping our relational rules in place, we'd have complex joins, which would then cause more issues for performance when we were trying to do things like aggregate calculations and join across many tables. And so this data, and then as the amount of data that was originating from the transactional backend systems accelerated, data growth was going through the roof. And our ability to respond to the business in order to get the insights that they were looking for, our speed to insight was decreasing. So with this pattern, what we had to do is we had to cherry pick. We had to figure out, like, what is the signal that we want to get through all of the noise of our data? And oftentimes we would do things like batch up jobs that would run maybe nightly, maybe weekly, sometimes monthly, that would crawl through these vast transactional systems in our backend. We would denormalize that data and flatten it out so that we could get more performant results. And we would have calculations run in these batch processes that would do our aggregation for us. And that is a way that we were attempting to work within the constraints of the server environment that we had, where we were limited in the amount of data we could store, and we were limited in the amount of compute power that we had available to us. And then the business would say, well, what about this other insight that I wanted, or tell me about what's behind this aggregated number? And we'd have to go back to the drawing board of source, and we would have to change our ETL process to bring in different data elements or bring in different levels of detail. And that would slow down the answers that we could deliver to the business. So there was hope, though, because with the advent of public cloud and with the advent of kind of storage as a utility and compute as a utility, we were no longer in a position where we would have to limit what we could store. The cost of storage has gone down dramatically. I do have graphs that were behind this, but I just wanted to draw this for illustrative purposes. So if anyone is interested in any of the research that I have, I think it's a Forrester graph that shows what the numbers are for the cost of storage. And the cost of compute has also come down significantly over the last 15 years. And there also are advances in the compute patterns that we use that has allowed compute power to accelerate upward. So what if we could store everything? And what if, even if we were storing large amounts of information, we could get to an insight quickly and we could crawl across that data quickly? And what if we could do this in a way that was affordable for organizations? And that's what kind of led us into the concept of modern data warehouse. And many of my customers that I talked to today are leveraging modern data warehouse patterns, although they are still, many of them, transitioning from the central data warehouses that are housed in their private cloud into a modern data warehouse pattern that is housed in public cloud. So if we're leveraging modern data warehouse, we have the ability to accommodate the concepts behind big data. So big data is one of the buzzwords that I was dealing with when I started at Microsoft 9 years ago. And I didn't love this term because I'm like, I don't really get why big data is any different than what we've already been dealing with inside of our organizations. So yeah, I get that there's a lot of data. Yeah, I get that it's coming from a bunch of different data sources. That's the same as what we have been dealing with in the data space the whole time that I've been working with data. And I read an article that was called The 5 V's of Big Data, and that kind of opened my eyes to why we needed to shift pattern. So the first V of big data is about the variety of data that's available to us. So in the central data store, on-prem relational storage approach, we were dealing with transactional data that would come out of relational data systems. So, but there is more types of data available to us that we could get insights out of if we could figure out how we could reason through that data. And examples of variety of data that don't follow the relational patterns include things like, what if you had images that you could get insights out of? What if you had blobs of data that you wanted to get sentiment, wanted to figure out sentiment from a blob of data? What if you had key value pairs that were coming from logs, or you had device telemetry that you wanted to include in your data story? The central data storage that was relying on a relational storage location wouldn't accommodate that. And then the velocity is the second V, at which data is produced today is like hockey sticking up. So with the advent of people always having a device in their pocket, we have a whole bunch of data that is flying at us at a rapid pace. We have subscription data that we can subscribe to, like around weather data or around geolocation information. We also have data that's being produced rapidly around the transactional systems. And in the old pattern, we are batching everything in. But what if we lived in a world where we could take advantage of the data as soon as it was published? What if that could become part of our insights? And then the third V of big data is about the volume of data. So I talked a little bit earlier about cherry picking that signal through the noise, but what if we didn't have to do that? What if we could just keep all of our data at full fidelity as it's being published? And then a challenge in the data world has always been data veracity. So how can we trust the data that's coming at us? And in the big data world, this veracity challenge is bigger because we have so much more data being produced at this rapid pace and of different types that we really need to have our arms around understanding the data lineage and the truth in data so that we can trust that we're getting real value out of that data. So this big data theme is what prompted that move from this central data warehouse into this modern data warehouse platform. So in this modern data world, we have some opportunities to look beyond what happened inside the walls of our organization and why, and we can start thinking about what is going to happen. And if we can think about what's going to happen, we might make some different decisions about how we're going to act. And then if we could even get beyond that and start shaping things, what can we make happen? Then we have a way that we can monetize our data and get extra value out of it. By the way, I'm a fast talker. So if anyone has questions or thoughts or comments as I'm talking, I do invite you to put them in the chat.
Oh, Valerie, by the way,
Yeah.
we do have one thing in here just while I got you here. So it's from Satya. He says, hope you might cover this topic, but can you talk about the data modeling relevance and importance in terms of Lakehouse pattern things? So that might be something you circle back to at the end, but just
Yeah,
so that's on your radar.
Yep, that is a great question. And as I talk about Data Lake and Data Lakehouse, I welcome you to follow on if you have additional questions after I've covered that.
Perfect, thank you.
Okay. So we're moving beyond in the data world today, analytics and business intelligence to advanced analytics, which can include things like forecasting. And we are also supporting now data sciences teams. So data sciences teams have very different needs for data than the analytic teams do. So what if we could support all of these types of analytics for business users, analysts, data scientists, and IT people, including giving them modeled data, as well as just giving them curated data so that they can do their own modeling on top of it, as well as providing raw data to them so that they can do exploration of the raw data in order to tease out patterns, which the data science teams do. So there's a lot of complexity going on here. And that brings us into a new pattern from Central Data Warehouse, where we are doing ETL, which stands for extract, transform, and load. And what if we shifted, by the way, the the extract, transform, load, the transform T ended up taking a lot of companies a lot of time, and that's where they were spending a huge amount of money, both in resource dollars as well as in compute dollars. What if we could switch this around so we could speed people to that insight? So a pattern of switching this around, which to me just looked silly at first because I'm like, big deal, you switch the letters. So instead of ETL, it's now ELT. I don't get it. But the concept here is, what if we could do that extract and that load, which is the first couple steps in your data pipeline? What if we could do that quickly because we just grab everything raw? What if we didn't have to try to figure out that signal through the noise? What if we didn't have to kick out data that didn't follow a schema that we anticipated? What if we could grab in data that wasn't relational and we could just load it somewhere? And then from there, we could do our transforms based on the business requirements. And in fact, what if we could treat those transforms as little tiny transforms so that we could work on them in parallel in order to get rapid results to the organization? So that is where the concept of data lake comes into the picture. Data lake is something that goes between your source systems and a model storage. If you have a physical model storage, like a data warehousing solution in the cloud, data lake is a middle zone. And that middle zone of data lake is intended to hold all of your data raw. So you just grab it as is and you do the landing in this data lake. You have opportunity to think about, if you're going to land things into your data lake, an anti-pattern is to land things without doing any kind of information architecture on your data lake. That's how you will end up with what some people have called a data swamp. So we want to make sure that when you land data in the data lake, that you're landing it in an architecture that keeps track of metadata of where the data originated, as well as you have the opportunity to have different zones in your data lake. Data lakes under the covers are file storage. You can store any kind of file in your data lake, and you can use like a file hierarchy structure in order to organize data that has come from different locations and on different dates. And you even can do things like I show in this picture, a raw zone that has data from different systems. Generally, that would be followed with time-stamped folders. And then you can have a different zone that will store data that has been curated as you are going through your data engineering tasks to prepare that data for modeling and for analysis down the road. So this is a picture of how the modern data warehouse patterns look. This is called a Lambda architecture, and it shows how we are grabbing from sources on the left-hand side, and the sources can include relational stores that are in a private cloud. It can include relational stores that are in public cloud. I don't show this here, but it can also include accessing stores that are like in SaaS, software as a service-based systems, where you are grabbing data via API calls. You can store files in here, as well as you can subscribe to data that's coming from sources outside of the walls of your business, or pick up device telemetry that is coming from IoT devices that you might have in your environment. And in this pattern, we want to be able to support both batching data in. So batching data would cover scheduled jobs that you would have running. Those scheduled jobs would generally grab data from source on a scheduled basis, and the data that it grabs could be up to large data amounts. The pattern on the bottom talks about streaming. So if we are hoping to get closer to real-time analytics, you might want to stream data in from sources. When we stream data, that's more of a listener model. So the stream will listen to source, and when the source publishes out additional information, it will ingest it immediately into the lake. Now, the stream path is anticipating that you're going to have small data packets that are coming in, and that the velocity of the packets can be high. So this is one way that we are accommodating velocity, and on the left, we're accommodating variety, but we're still able to join all of that data into a data lake storage location that will allow for non-relational data store. And from there, I have a little cycle on the top of that data lake thing that says prep. So the pattern here is when we are moving data through our data pipeline, we can start off with this raw dump, but then we can pick up the data and we can do some cleansing. In the prior slide, I called that curated data. So we might want to do things like get to a common date format. Maybe we want to get rid of null values out of data sources and ensure that we have quality. We also might want to join data from a couple different systems into object level information in the curated zone in your data lake. And then from there, when you want to start modeling that data together, you can publish that data out into another physical store. And in this picture, I'm calling it data warehouse. And there are different technologies that you can publish models into. Data warehouse is a generic term. I'm drawing the shape there for an Azure data warehouse. And then that data warehouse is what your reporting dashboards could reach into in order to grab their data. You also might have some applications that would be looking for that data that's already been cleaned up, modeled, and prepared for them. So this is the modern data warehouse pattern. And it introduces us to the idea of data lake. I don't have data lake in my terms that I had in the beginning, oh my, but all of these things kind of build upon each other. So I wanted to hop into that. I'm going to talk about Delta Lake in a second here, but I wanted to double check on, is everyone with me? Are there any other questions? Because I see a few chat things it looks like.
Hey, Valerie, this is Satya. Can I ask a quick question?
Please.
So even with the modern data warehouse architecture, we still have the velocity issue, right? So let's say business has a BI requirement that has changed, and they still have the dependency on IT because they have to do the data modeling for them, with the data warehouse in the middle. So yep. Go ahead.
Yes. You are right that what this pattern has done is it's helped shorten the time that it will take for IT to respond to a request from business for a new aggregation or a new insight, because IT won't have to go all the way back to source to start over. They can do it from data lake. But there are other patterns that I'm going to talk about coming up, Satya, that supplement, and then at the last pattern kind of shakes this all up totally.
Yeah, I'm looking forward to that.
Yeah. Okay, thank you. So now one of the patterns that has been, I think I probably first heard the word Delta Lake a couple years ago, but Delta Lakes are being adopted by many customers, and Delta Lake is it's not a product. It is a pattern that you can lay on top of your data lake. And if you see in this picture here, in the previous one, I had system one. I don't know if I said .parquet in that one, but Parquet is a file format storage type that is optimized for read. So, and Parquet allows for schema drift, but describes schema. So you can deal with Parquet files in a way that's closer to how you might deal with a relational data store. Delta Lake, what Delta Lake does is it's a pattern that is overlaid on the data lake. And it shows up as a Parquet Plus file extension that appends additional metadata about the data that is contained within the Parquet file, so that you can leverage a Spark-based engine to read the data out of your data lake as if you were reading it out of a relational store, where you could, it manages things for you like upserts and deletes on data as it flows in. So if you think about this data lake, initially you're doing a load of data, but then after that, you're just pulling in incremental change. And in order to reason through incremental change, that's in a whole bunch of different files to understand what your data looked like at a point in time, you can do that without Delta Lake, but it would require many lines of code for you to figure out, what did my data look like yesterday? What does it really look like today? Because you'd have to look at that source file and all of the incremental change sets that have come for a specific record, if you will. So Parquet Plus is a pattern that you can implement in your data lake that allows you to leverage just some Spark-based keywords to get to that time travel of your data without you having to write a whole bunch of lines of code to manage the incremental change. So did that make sense to people? And by the way, Matt, I love that you have your video on, because otherwise I feel like I'm in my basement talking to myself.
I've been there before.
Yeah, so thank you. I wish you guys were all at the Microsoft office. Okay, so that's this concept of Delta Lake. So Delta Lake is not a replacement for Data Lake, nor is Delta Lake a replacement for anything that was in the pattern that I just showed you above. What it is it's an additive pattern that you can use with your data lake in order to enable you to leverage a serverless compute engine to do ad hoc query against your data lake as if it were a relational store. So Delta Lake is, I am encountering Delta Lake in most of my customers in as far as they are interested in it and they're trying to figure out how they can leverage it in their current data approach and data strategy. So Delta Lake has a lot of legs. Databricks has published out and made, and they actually shared it out, the Delta pattern. They shared the IP for that Delta pattern broadly with the Spark-based community. So it is public code, but they have an implementation of it that's very nice and clean. So Databricks is an example of a serverless compute engine that you could use to leverage the Delta pattern. They also have a whole bunch of documentation on how they recommend setting up your data lake, how they recommend the information architecture containers look, how they recommend that you unify your batch and stream ingest processes so that you only have one pattern to follow. And I have a slide in my deck at the end that includes a bunch of links to documentation, and it does include a link to the Databricks documentation. So that they were kind of the first to market on the concept of Delta Lake. So with this picture that I drew here, you'll see that I have the yellow that I added in, that is the serverless compute engine that can access these files in your data lake, your Delta Lake files in data lake, in order to allow you to quickly get to joining and querying that data as if it were relational, using a few keywords to allow you to pick a point in time that you want to understand what your data looked like at. So a pattern that I am seeing with my customers is they have a path where their IT group is getting everything into this data lake and the IT group is preparing the models for the data warehouse, but they also have analysts that sit in the business and the analysts want to be able to do their own exploration on top of the data. And so their analysts can do ad hoc query leveraging the serverless compute in order to ensure that they are not impacting performance of these reports, these organizational reports that are published out in the dashboards that are relying on this data warehouse. So they can allow analysts to do their work on a separate stream, on a separate compute line. And if their analysts are producing something of value, then they can have a process in place that says, let's get this incorporated into our data warehouse. So Satya, this is not the throwing everything on its head that I was talking about, but this is one way that organizations are trying to enable analysts outside of IT to be able to do their own sandboxing on models that they would like to append into the overall model approach for their business group in order to feed them to insight. So this doesn't have to be the be all end all, but this is one pattern that I'm seeing getting used a lot.
Can I ask a quick question? How do you have any recommendations for metadata management? I think metadata management becomes a challenge when you have multiple sources and different source of truth for the business.
Yeah, so I am not going to, I don't have a drawing of that, but so I'm just going to answer it right now for you. So underlying this pattern, if I'm drawing this out in whiteboarding sessions with my customers, I will generally do a rectangular box that goes across the bottom that is foundational to this whole system. And that box will include security. It will include lifecycle management. So you should manage your data assets in the same way as you would manage coding assets with check-in, check-out, deployment, having different environments set up so that you can get a CI/CD pipeline going. And there is also in the Microsoft portfolio, I have a tool that's called Azure Purview. And Azure Purview is a tool that is used to help you understand what your data glossary is. So that you can get to a semantic layer, as well as gives you pictures of your data lineage so that you can track data as it is moved through different steps in the pipeline, as well as will crawl through data sources and tag your data for you so that you understand if you have PII or if you have other pieces of data that you need to apply policy on top of in order to remain compliant. So that's a tool in the Microsoft portfolio. There are other, but I will say that Purview right now, Master Data Management is a roadmap item for us. So we leverage, I recommend people work with Proficiency. I think that's the wrong word. Let me get the word to you for the Master Data Management tool. Prophecy, P-R-O-F-I-S-E-E. Prophecy is a tool that is a company that focuses on Master Data Management specifically and integration with the Microsoft portfolio of tools. Now, if you're working outside of the Microsoft portfolio of tools, I know that Informatica does a nice job with all of those things, but Informatica is a heavier tool and you have to have a fair amount of maturity, I think, to implement Informatica well. And so, but there are definitely tools to help with that. But I will talk about, when I talk about data fabric, I'll kind of touch on this a tiny bit again.
Awesome.
Absolutely, you need to understand your semantic layer and have data governance. Otherwise, this is just a giant old mess.
Exactly.
Yes.
Thank you.
Yes. And so on this slide here, what I attempted to do was to help tie back to that earlier slide where I'm like, in the modern data world, what if we can enable different people to self-serve? So as we are looking at this picture, it is true that you still have data engineers who are responsible for that ingest and getting it into store. And data engineers might be the ones who are responsible for the prep, although you could start crowdsourcing prep out to analysts potentially. So I have analysts who are there doing their own ad hoc query and exploration of data, and they can look both at the data that's been modeled officially through the IT Blessed channel, as well as accessing the data that has been curated into the data lake, leveraging that serverless compute so that they can start building up their own data assets. And then there generally is some kind of I want to graduate something that an analyst did in sandboxing to something that's part of my physical store. So I want to kind of switch over that data warehouse path. To me, that is a physical storage location, and you have multiple physical storage locations available to you. And this yellow path on the bottom is a logical. This is about logical modeling, so that you can do things like have notebooks that define this logical model that can then get accessed for different purposes. And then, of course, your business, they're accessing the reporting and dashboarding, but most of the reporting and dashboarding tools on the market today will allow the business to start with the dashboard that exists and interact with that dashboard, where they can do drill through, so that they don't have to go back to IT and say, oh, where did that, how did you get this number? They have the ability to investigate down different levels. Most of these dashboarding tools also have the ability to let the business start with a visualization that's been built and do some of their own visualization builds on top of it. So there, the business they're not analysts, they're not creating models, but they can create some of their own visualizations based on models that have been published for them. So that's a way that we are starting to move toward how can we really get the business closer to self-service. So we started off with the central data warehouse, and then we talked about modern data warehouse and how data lake and Delta Lake are additive patterns on top of modern data warehouse to help you get closer to that promise of big data and getting you closer to speed and agility of allowing new insights to flow into the business. So now we are going to talk about this pattern here. So we talked about having Delta Lake. We have this raw and curated in the patterns that I showed above, but this Delta Lake has really unlocked a question of what if we went towards more and more logical models? What if we didn't have to rely on a physical store that was a physical relational store? What if we could stay with this low cost storage place and we could put our model data, keep our model data right in our data lake? And then we could leverage our Spark-based compute to access the data out of this data lake, and it could still be performant because we're leveraging a clustered compute. And this clustered compute can read across large data sets, and we're not going to run up against storage limitations because our data lake is cheap and we can just keep growing it. So that's what this is here. I added on this yellow model data. What if we kept our model data in our data lake? So that is where we could look at a pattern that would be something like this. What if we removed the data warehouse from our picture? What if instead our storage was all kept in our data lake and we kept our compute separate over here in a serverless compute cluster? And what if that is what we used for our reporting dashboards, for any API calls, and for the ad hoc query? What if we were to do that? That simplifies our picture in a way because we've removed a copy of data, although kind of we haven't, we just put it in a new spot, but we have it all contained in this data lake, and we don't have to have a different data storage location that we have spun up. So this pattern here is called Data Lakehouse. So Data Lakehouse, we had in our data warehouse in that physical store. That physical store is a combination of storage and compute that's optimized for quick read for our people who are accessing the models, versus the pattern I just showed you now completely separates out the compute from the storage. And we say, why don't we get rid of the storage plus compute combo and leave our storage data lake and leave our compute in our serverless compute model? And you can have multiple compute clusters so that you are breaking up workloads, but that's what this pattern is all about. So that is the concept of Data Lakehouse. Now, I will share with you that when I first heard that, I'm like, yeah, that sounds cool. Let's have Data Lakehouse replace our data warehouse because I like less jumps. For me, keeping it in that lake seems like I have one less service that I need to monitor and govern, and it seems like I'm simplifying my picture. However, if we were to put everything in this Data Lakehouse pattern, one thing to keep in mind is that every time that your logical model is called, you are going to pay for compute. So if you have heavy compute that needs to occur in order to serve up that model, which you could mitigate that by adding in more aggregations into the model data that you're storing in the model container. But still, you are going to pay a compute every time that that model gets hit. And there might be, and when you're hitting through the Spark cluster, it's not going to be quite as performant right now as if you're using for your data warehouse a multi-parallel processing data store. So that is one drawback of going with the data lakehouse across the board pattern. Another thing that could be a drawback is when you are leveraging your physical models and having your Spark notebooks, or you can also have SQL Pool notebooks do the same thing. But when you're having these notebooks create these logical models for you, you also need to put in security in the model definition. So you're going to have to ensure that every model has security set model by model, where if you're going with a physical storage location like a data warehousing solution, usually you can do row level security in the data warehousing solution at a top level, and then you don't have to worry about it being done in code. So that's another thing that can be a drawback of doing straight data lakehouse. But I personally think it's a very interesting pattern. And I have done a lot of reading on it and researching on it to try to figure out, when I'm working with a customer, what is the right use case where I want to say, I think you should consider a data lakehouse for this. And are there use cases where you might want to do some of each? So this is an example of a whiteboard picture that I worked on in telling stories with my customers when they're in my MTC session with me. And what I am finding in today's world, and this doesn't mean this is going to remain the case, but in today's world, I generally find that it's kind of a better together approach. So what if we could have there are some use cases where we want to store a physical model out into a separate physical store. These are all Microsoft technologies because I work for Microsoft, but physical model, logical model, you can plug in whatever technology you want to underneath the covers there. It's conceptually the same thing. So the idea here is there are cases where we want to have that model data stored in the data lake, and we want our analysts to be able to access the models there for ad hoc query. However, we might want to also have some models that we're publishing out into a physical store. And generally the models that we'll publish into the physical store are the models that are being leveraged for your organizational wide BI dashboard reports that are being run over and over and over and over and over, and whose data doesn't change super quickly. So the other thing that's good about having your data land in your data lake in the modeled zone, true, there still will be some time that's taken for the data to be processed and get into that modeled zone, just like there would be up in the physical model world. But if you are going through and doing that recalculation frequently anyways, you might want to stick with the logical model because you want to go get fresh data every time. So I generally am seeing customers use a combination of a physical data store for models as well as a logical model store, where they are leveraging they're leveraging Delta Lake and Data Lake in Data Lakehouse in conjunction with Data Warehouse. So it depends on the workload. Okay, now there's still a ton going on here in this picture. And Satya asked about, what about the semantic layer? What about master data management? He didn't say it exactly that way, but that's what I heard. What about data governance? What about all that stuff? And what about all that stuff is a legitimate question. And there are a bunch of different technology solutions that you can use to address this question. What about all of this governance? What about all of this security? What about privacy? What about data virtualization? What about all that? That's where the term data fabric enters our story. So data fabric is pretty new. For me, I didn't start hearing about it until maybe a year ago. And when I started hearing the term data fabric, I'm like, what the heck is data fabric? And I would read up on data fabric and I'm like, so data fabric is just data governance because we already do that. So what I have come to learn is that data fabric is a term that can be used for all of the things that I have written out in white here above the data fabric term. But there also are some companies that have produced products that they are selling called data fabric products. So it is a technology that you can buy and implement. I personally have not done that, so I can't tell you how successful they are, but that's where data fabric started getting legs, is when we had companies that were producing a solution and they're saying, hey, let us help you with all of the messiness of governance and let us help you get it right. And we have a product for you that you can plug and play. So data fabric then would act as this kind of door in between everything that's going on to the left and all of the consumption things on the right. So the right-hand consumption things would reach out to the data fabric tool, and the data fabric tool would know what to do. So that is where data fabric comes into play. Now so here we have data fabric just in this little journey line, pointing out that data fabric is not a replacement for anything that was in that picture. It was additive. So it's something that you can do in addition to Data Lakehouse and Delta Lake and Data Lake and Modern Data Warehouse in order to help you manage that, the complexity of governing everything that you have going on and giving easy access to your business. Okay, but there's still a lot going on in that picture, right? So, by the way, I'm not going to give you a here's how everything is magically easy, because it's not. But with all the stuff that's going on in the picture, there's a lot to manage. So there's complexity in managing the integration between all of those different services. By the way, there are things that Microsoft and Snowflake and other software companies have done in order to try to help your data teams by giving you solutions. Snowflake talks about how they're kind of a one-stop shop for all of the boxes that I had in the picture before. In Microsoft, we have Azure Synapse Analytics to be like, what if, you need all of these capabilities, you need them. But what if we made it easier for you by packaging it up into one pane of glass for your data teams to work in, whether they're a data engineer, whether they're a data scientist, although I think data scientists still kind of have their own special needs and operate in some other tools better, but integrating in with any of the data science tools, whether you're a data analyst, what if we could just toss you into one spot? What if that one spot pulled together the data lineage picture and allowed you to create visualizations so that you didn't have to bop around between services? So that's technology companies are doing things to try to help make this complexity less complex, but you still are going through all of the same steps. The other thing that Satya brought up is in the picture, true, we are trying to help the analysts do some of their own modeling sooner in the data pipeline. We are trying to speed up the time that it takes IT to get extra data added in by grabbing everything raw and putting it in that data lake. But we still have the potential to have IT be a bottleneck for us, because IT is owning the source to data lake portion of the data journey. So this centralized data management is good from the perspective that your IT team understands security and privacy and governance, and they understand how to cleanse data, and they understand all of the data engineering things that they need to do in order to make sure that you have data of high quality, when we talk about cleanliness anyways. But does the centralized IT group really understand the data? Like, they're not the ones who worked on producing the data, so they understand data concepts, but do they really understand the data that they're looking at so that they can help make good decisions about what you should do when you're going through and deciding whether data is of high quality? There's still time if an analyst is something that is for some reason not in the lake, that they have to work with IT to get IT to understand their requirements so that IT can build it out for them. So there is still a bit of a bottleneck, even though we've relieved it somewhat. And is there really enough agility in this pattern? Again, to what Satya said, how do we, if the business asks for something, we're still not able to get turnaround generally in a day, are we? So it seems like there still are some opportunities for us to improve upon this pattern. And latency and data consumption is another one. So we have data going through this step and then this step and then this step and then this step. So even if we're trying to stream data in to get near real-time analytics, I would never promise real-time analytics. Like if we're NASA and we're flying to the moon, we're not going to send our data through all these steps before we let the astronauts know that they're going to crash. So, I mean, so that stuff is still a challenge, and it's a challenge for all data teams. So that is where this concept that data mesh is a brand new pattern. And data mesh is attempting to solve some of these things. So there are some key goals of data mesh. So one of the key goals in data mesh is, what if instead of having this centralized data lake idea, which is faster than the centralized data warehouse, okay, but it's still not as fast as the transactional systems that are sitting in the domains. What if we decentralize that? What if we had each domain own their own data? So what if we put data engineers in each domain team, and we had the engineers in each domain get very familiar with the data in that domain, and we had each domain create their own data products. And when they created their data products, they would have APIs available to the rest of the organization to consume their data products, but everything's there. They know the data, they know how to work with it. They don't have to wait for IT if they're trying to get to their own insights that the business is asking of them. So in this domain model, an example of domains would be like HR could be a domain, and finance could be a domain, and sales a domain. So we could let each of the domains have their own resources sitting in their group who knew their data very well, who could quickly respond to the changing needs of their immediate business, and then also could publish out information, but not to another store, in the format of opening up an API endpoint, so that if others in the organization needed to consume their data, they could. But what if on top of this, we did still have some centralized stuff, because we want data governance to be handled centrally. Like, we want rules about how we're going to govern our data. We need to have privacy rules across the organization that is implemented the same no matter where the data comes from. And we also need to know, where do we go to get these APIs? Like, how do we get to these endpoints? And how do we know which endpoint we go to in order to get the data that we need? So the concept here is having the domains handle their own stuff, but then having IT centralized governance on top, infrastructure on the bottom, is how it will show up in the next picture. So this is a hope of, like, is it the best of both worlds? Now, when I look at the picture, I have a million questions, a million concerns, a million places I want to dig in. And so I did include at the end of my presentation a million links for places that you can go to learn more, because I think that we could talk about data mesh for an entire day and probably still not have it all unwound. So this new pattern here, it looks like this. So we have and I grabbed this from Zhamak Dehghani. So Zhamak Dehghani is I believe, the creator of this pattern. So I included a link there, and you can hop out and read her stuff. And when I looked at this, before I was in the data space, I was more tightly in the application development space. And in the application development space, we went from the idea of having legacy monolith systems into having microservices. So in my mind, when I look at this, I feel like this is like data as a microservice. So how can we break down dependencies between these domains so that they can do what they need to do at the speed that the business needs, but allow joining data across those through this API endpoint? So we have this decentralized data product ownership where we have engineers hanging out in each of these groups, and then they are producing data products for their own internal consumption, as well as products for the rest of the organization to consume as a data service. And then underneath it, we have IT. So we have the infrastructure managers. I have read patterns where organizations are saying, okay, for each of these little data decentralized areas, IT is going to provide a pattern saying, these are the technologies that we want you to use. This is how we want you to implement it. And then the domain group would implement their solution with the pattern provided by IT. Although there are other patterns where IT doesn't do that. They say, do whatever you want in your domain group. If your domain group is using a graph API, awesome, I don't care. As long as when I need to access the data, you have an endpoint for me that will allow me to consume. So maybe the data infrastructure is just helping with the discoverability and ensuring that discoverability is done consistently. But they're also helping with access control. They're helping with any kind of storage that they need to help with, but they're not owning it. So that is the idea there with having your data infrastructure as a platform. And then IT or a group of other people within the organization, but in a centralized manner, are then responsible for this federated governance. So ensuring interoperability, ensuring that you have master data management handled, ensuring that you have a semantic layer so that you know where to go and all that. So this is what the data mesh picture looks like. So in my other picture, which I don't have that right here, I'm not going to pop back to that slide, but I started at source and then I went into this pipeline thing or doing ingest and batching and streaming. So this gets rid of the batching and streaming, although I assume that you still would have your transactional processing system would be different than the analytic system, but each of these domains gets to own their own analytics system and they can decide how they're flowing data in, and that's not the business of anyone else. And so IT in this picture shouldn't be a bottleneck anymore. But now I don't know that I feel like this seems any less complex to manage. Personally, I feel like the managing complexity has increased with this picture. So I'm interested to learn more about patterns around how you would manage this. So have any of you heard anything about data mesh that you would like to kind of toss in? Oh my gosh, and we're almost at time. Okay, since we're almost at time, I'm sorry. There are 10 things in chat. Leah, would you like to pull out a couple?
Yes, for sure. Let's see here. Terrence commented, you asked the key question, Valerie, how can we break down dependencies between these products? Otherwise, everyone is recontextualizing the data on their own. So it sounds like that resonated with people. And then.
Thank you, Terrence.
Yeah.
He's my buddy. He's my MTC buddy.
And then Satya, you also asked, can I add one more, a little more complexity to the equation? How about data lineage? So that was a little bit into your presentation there.
Yeah, so data lineage, I touched on that a little bit. Did you have more questions about it, Satya?
So would you recommend Purview as a data lineage tool from Microsoft side?
Yes.
Okay, that's what I thought.
Yes. If you want to reach out to me afterwards with any other questions, I'm happy to field.
Yeah.
And then Matthew, you also had a comment. I was wondering why the serverless was only for ad hoc. Nice setup. So that was more of a comment.
It was a beautiful setup there. I liked it.
Thank you.
All right. And I think that's it. We pulled out everything in there.
Okay, so here we go. Data mesh is still a question mark in my mind about how that's going to actually look. I do know that there's a team of people at Microsoft who are talking about how if you wanted to implement data mesh, what it would look like in our product set. So keep an eye out for that. And I do have a slide. So concerns with data mesh are listed here and keys for successful data mesh. By the way, I pulled a lot. I picked the brain of James Serra. I don't know if you guys are familiar with who he is, but he is also another buddy of mine at Microsoft that it's funny, every time I search for a data topic, his blog is the first thing that comes up in my results set, James Serra. But anyways, so I got the idea to do this from James because he does a similar presentation. And so a bunch of the links in here are his blog posts. I think James does a very good job of explaining things in like normal language that you can understand and not getting too techno geeky immediately, although he has some techno geeky one blogs as well. But so a whole bunch of links here for you. In data mesh, you could read on that for weeks and not have covered all that's been published. But then I thought, well, you know, who should really consider this? I liked this slide. James created the slide for one of his presentations, but grabbed it out of, I think it's out of a Gartner thing. But so you can review that. And there's some discussion about the buzzword of data fabric versus data mesh. Although in my mind, the biggest difference is data fabric is additive to what you already have. Data mesh is taking your pattern and flipping it around on its head. So there's some comparisons there. And then if you are interested in case studies on organizations who have implemented data mesh, there's a link to organizations here. And if you are interested, if you are a Microsoft customer and you're interested in what Microsoft is thinking around data mesh, there's a bunch of links to resources that we have published. So that takes us to the end. Thank you guys. I really appreciate you hopping on today, and would love to meet you all in person. Maybe next time we could have one of these days hosted at the Microsoft office.
Awesome. Thank you so much, Valerie. I will say I don't come from a technical background, and I thought this was fascinating. So this is a great starting point, I think, for everybody to really dig into what options would work for your organization. And Valerie, are you okay? I'm putting you on the spot here. Are you okay if people reach out to you and like follow up with any questions they just didn't think of during the presentation?
Yeah, absolutely. Absolutely.
Perfect.
And I don't know if you're sharing my email address, but I share it with all my customers. So it's just first not last name at Microsoft.com. I also keep an eye on LinkedIn, not as much as I do on my email, but if you message me there, and you can connect with me on LinkedIn too, if you are interested in seeing how everything progresses. I try to share things that I hear from the field and put them in my LinkedIn.
That's awesome. Perfect. And I will send this recording, a link to this recording out to all of the participants today. Even if you had to drop a little bit early, people will be getting them. And then we'll also send out your slides as well, so people can use these great resources that you've listed. So everybody's getting a lot of, a great list to just really dig into and do their own research for their organization, which it's so helpful, Valerie. Thank you so much for doing that. So,
well, thank you. It was really fun to meet with you guys today.
All right. Thanks, everyone.
Thank
Have
you.
a good rest of your day.
Yep. See you all soon.
Take care.